Hello, guys. What's good, everyone? I'm back at it solving some lead code problems. Yesterday, I was trying to solve this substring problem whose name I don't remember. Submissions, I guess. Recent AC. Discuss. Isn't there a tab for recent submissions? Anyway, let's go back. I think I'll just pick up a new problem. I haven't yet solved it, but I do think that I have the right answer now. Um, or maybe I'll just discuss this with ChatGPT and uh, just have that verification of my proposed solution just to make sure that I have the right answer. Mm, We have a string S. We need to find the smallest substring within S, which contains all of the characters present in the string T. Mhm. Yep, this was the question. We need to find the substring. We've got to find the substring in S, which contains all of the characters present in T. And my proposal was that we're going to have two pointers. We're going to have two pointers. Initially, it's going to both be at index 0. I'm going to move the right pointer towards the right, and each iteration, I'm going to record the character which I'm hovering over. And if it satisfies any of the requirements, which it will do by having the same character as what's there in string T, and I'm going to keep moving R until all the required characters are satisfied. Let's say that condition is triggered somewhere over here, which in the example, I think the string S is uh, this thing. It's Adobe Code Bank. And string T is ABC. So when my left is at A and right is on C, this is the first instance where the condition is going to be satisfied. Now I'm going to record this as a valid answer because it is. It is a valid answer. It might not be the most optimal answer, but it is a valid answer. So I'm going to record left and right pointers, and I'm going to record the length of this substring for future reference. The next step is to try to minimize or reduce this substring. Is it possible to make this substring any smaller while still making sure that the criteria is satisfied? That is what we're trying to answer. And for this instance, this substring, that is false. We cannot reduce this any further. So what I'm going to do in that case is just move left one step to the right. Now my condition is broken. This is no longer a valid substring. I got to find another A to make this a valid substring. So I got to move right to the right till the condition is whole again. and that's going to happen when R is on A. Now I'm going to ask myself the same question once more, and which is this valid answer reducible? Can I make this substring which satisfies my condition any smaller? And the answer this time is yes, this can be made smaller, and I can move L all the way to C while still having the substring be valid, because C, we have C over here, we have B over here, and we have A at the end. I'm going to repeat this once more. I'm going to move left. I'm going to first record this answer as a valid one. I'm going to compare this with the previous answer. If it's smaller, then that's good. I'm going to record this as a new best answer. If not, I'm just going to move on with left at O. Again, the same thing. And eventually I'm going to land up at the answer as bank. This was the proposed solution. Now that I think about it, I think this should be easy enough to implement, but I still don't want to waste time. I think I'd rather solve a no problem, because we're in the era of agentic coding, and I think it's enough to have the pseudocode in mind and have that clarity of the pseudocode, and just let the machine handle the translation of that vision into whatever language you're working with. So I'm going to do just that. I'm going to go to ChatGPT and try to get a working piece of code using my vision. I'm trying to solve a problem called minimum window substring. This is a popular LeetCode problem. I might have the wrong answer, and that's perfectly cool. What I just want you to do is I'll tell you my approach, and I want you to translate it into code. So here's my approach. The problem statement is we gotta find the smallest substring in a string S, which has all of the characters present in string T. And here's my approach. I'll have two pointers, left and right. Let's call them left and right pointer. And both of them are going to be a 0 in the beginning. Next, every iteration, I'm going to move the right pointer towards the right. I'm going to increment that. And I'm going to keep doing this until the condition is met. The condition being that the substring between L and R contains all of the characters present in the string T. Now, the first time the condition is met, I have a valid answer. This might not be the optimal answer, but this is a valid answer. So what I'm going to do next is try to reduce the substring which I've got, because it is valid, but I'm going to check whether it's possible to make it any smaller. And the way I'm going to do this is by moving the left pointer towards the right, or incrementing it in other words. And I'm going to keep doing this until the condition breaks. And each time when I move left, if the condition still remains valid, then I'm going to keep updating my best answer seen so far, because the substring definitely is smaller than what I just saw. So I'm going to keep moving left to the right until the condition breaks. And when the condition breaks, I'm going to let it break. And next, I'm going to start moving the right pointer to the right once more, because we just lost the leftmost character, right? So the string is no longer valid. So I need to recoup that lost character by moving R to the right once again. And this is what I'm going to keep repeating. Next, again, we're going to land at a valid substring. It might not be optimal. It is definitely valid. And since it is, I'm going to try to reduce it by moving left, and just keep repeating this over and over again. And I'm going to record the best answer seen so far, and that's what I'm going to return. So can you translate this vision into code for me? Okay, so is my approach the right one? Is this what's expected in interviews? Okay, so I got the right answer. Combination sum, jump game. Uh, let's pick this because this tells me, kind of like teases me, uh, because I feel it is about graphs, and I used to absolutely love solving graphs problems. Yeah, graph problems are the best, and dynamic programming is also up there as one of the most uh, interesting uh, competitive programming problems to solve. I think that's like the best way to mentally masturbate. If you if you humor me, because you feel really good after having solved one of these problems, either graphs or dynamic programming. You're given. I think the font might be a bit too small. You are given an m cross n integer array grid. There is a robot initially located at the top left corner, that is grid 0, 0. The robot tries to move to the bottom right corner, that is m minus 1, n minus 1. The robot can only move down or right at any point in time. An obstacle and space are marked as 1 or 0 respectively in grid. A path that the robot takes cannot include any square that is an obstacle. Return the number of possible paths that the robot can take to reach the bottom right corner. And m and n have a constraint of less than equals 100. Backtracking is uh, the first thing that comes to mind. I think backtracking is definitely a way to solve this, but I don't know if that is optimal. But I guess you can make it optimal by using memoization, and convert it into a DP problem. Let's bring up the iPad. We've got a grid. Let's think about it this way. From here, if there are, let's say, 5 ways of reaching the end, and let's just assume that I know this already, uh, and from this point there are like 3 ways of reaching the end, then can I use this information to derive how many ways I can get to the end from this point? I think the answer is yes. It's going to be the sum of the two, right? Exactly. So I can just start from the bottom right, and the answer here is going to be 1. The answer here is going to be 1 again, and 1 again over here. And at this point, it's going to be 2 because you have 2 ways. You add both of the adjacent values together. Uh, it's going to be 1, 1, 2. No, this is going to be 3, I guess. Yeah, 3, 4, 1, 3. 6, and so on. Yep, I think this is the solution then. Yeah, it's super easy. It's just a memorization problem. And I feel confident enough to be able to solve this without needing ChatGPT. Vector int memo. How do I initialize this to all zeros? And I think the initialization should be with -1 and not 0, uh, because how do I don't know. I think it can work either way. But let's do -1. I just feel comfortable with it because of reasons I don't know yet. It's just a sixth sense, I guess. Now let's iterate over obstacle grid for int I is equal to rows minus 1, I greater than equals 0, minus minus I. We're going to be starting off this nested for loop at the bottom right index of the grid. Int possible paths left is equal to, uh, I'm going to check if I plus 1 is greater than or equal to rows, and j plus 1 is, I think it should be or j plus, wait, I think this, you just need to check for j plus 1 because I plus 1 means that you're looking down, and in this variable we are looking towards the left. So it's going to be j plus 1 is greater than equals cos. If yes, then 0. If not, okay, never mind. I think it should be 0. And you know what? I think let's make the memo grid one size bigger. I think this is going to help simplify the code because I don't have to worry about looking up the invalid indices. So this is going to be memo j plus 1, and another thing which is memo rows minus 1 calls minus 1 is equal to 1. Or I guess a better way of doing this would be if I equals row minus 1 and j equals call minus 1, then memo ij is 1, and just exit out of the loop. int possible paths down is memo I plus 1 j. And what if we are at an index, at a set of indexes which is marked as an obstacle? If obstacle memo 0 0. Cool. I think we have the answer. This was spectacularly easy. Okay, it's rows and it's calls. What's wrong? Okay, it should be no, what's wrong? You're at 3 2, which means that this condition is not going to be invoked. 3 2. 3 2. Why are you at 3 2? Because it's rows minus 1, right? Oh, wait, I forgot to get rid of this. Oh, okay, no, you need to have that, but you need to make sure that this starts at rows minus 2 instead. Okay, in this example, this is going to be 1, this is going to be 1, 1, 1, 1, 1. So this is going to be 2. So in theory, your answer should work, but something's wrong with the implementation, I guess. I think I need to have a printer function. Int I is equal to 0, I less than. Okay, this is supposed to be calls. J is equal to 0, j less than rows plus plus j. Cout memo I j. This doesn't look right. Okay. This looks right. Okay, it's 0 all over, which probably means that this condition, okay, it should be minus 2 here as well. Okay, I think now it should pass. What's wrong? Oh, I'm never setting the memo when we come over here. So it should be possible paths left plus possible paths down. Let's go. I think this should be the right answer. Let's get rid of the loggers and submit this. Okay, something's wrong. Uh, in this case, the obstacle. Okay, what I gotta do is check if the bottom right cell, if it's an obstacle. If it is, then there's no way to solve this maze, right? So you just gotta end your processing and just return a zero instantly. If obstacle grid I j return zero, cannot be represented. Okay. Okay, there is an integer overflow. I'm just trying to think how this could happen because they say that the answer will be less than whatever 2 billion, but I guess there is an intermediate uh, step where there is an integer overflow. So you can solve this two ways. I think you can just increase the bucket size to long int, which gives you a much more flexible way to store large numbers. But I think that is the wrong way or the wrong approach to this because that isn't infinite. You know, even it can overflow eventually. So is it valid to just stop and return zero, uh, or you know set the number the grid's value to zero the moment it overflows uh, because given this condition, I think that eventually that uh, cell with a really large value is going to fizzle out and uh, not be reachable from the initial cell is what I think. And where is this happening? Cannot be represented. Line 21. If possible, if possible paths down is greater than int max minus possible paths left. Let's see what happens. I'm just curious. Yep, great. So I think my explanation was the right one. If at an intermediate stage, if the value of a cell overflows, uh, then that just means that this cell which I'm at right now doesn't connect to the starting cell because the question mentions that uh, the answer is never greater than int max. So that's solid logic. Oh yeah, let's get this one. Given two strings s and t, return the number of distinct subsequences of s which equals t. The test cases are generated so that the answer fits on a 32-bit signed integer. Okay. Hmm. Return the number of distinct subsequences of s which equals t. Okay. I think a subsequence is defined um, by, you can remove characters from S. You can remove as many characters as you want from S, and that is how you get a subsequence. So with rabbit, with the three B's, you can remove any character you like uh, and any number of those characters, and the remaining characters, you join them together, and what you end up with is a subsequence. So the output is 3 because you can remove any one of the B's and have it be equal to T. So the output then becomes, 3 because, there are 3 B's. I think you got to use dynamic programming at some level to solve this. Hmm. What are the constraints? I think that is a really important clue. Okay, it's 1,000. So it's got to be under, I think, n square. It cannot be more than n square, definitely. Maybe n cube, but yeah, n square is, I think, where it's at. Okay, let's try to break this up. I'm just gonna arbitrarily choose a middle point and let it be the first B, RAB and BBIT. If I know the answers for the two substrings, can I derive the answer for the merged substring? The answer is no. I don't think such a function exists. What about knapsack? Okay, this reminds me of knapsack because I guess let me look up knapsack because this is an algorithm which I've forgotten all about. Or let me ask ChatGPT. What is the knapsack algorithm in dynamic programming? So you're given a set of items and you have a bag. And okay, so it's maximizing total value. I don't want to maximize any kind of value over here. I need to like find all of the substrings which satisfy the condition. Mm, So this might not be it. Okay, let me look at the hints. Finally, a solution which requires, the knowledge of an algorithm or a data structure, which I, don't know much about. There used to be a hint tab. What happened to that? String dynamic programming. Okay. I'm trying to solve this problem called distinct subsequences on LeetCode. I am stuck. I mean, I've hit a wall and I don't really know how to progress. So, can you give me a hint? I don't want you to give me the full answer. I just want you to nudge me in the right direction. I know that this is a dynamic programming problem. Uh, I thought that maybe Knapsack could be of help, but I don't think so. I don't think this is relevant. Can you give me a nudge in the right direction? Oh, okay, got it. Got it. Oh, I've had a viewer. I think the initial thought, which was to try to break the substring S into two, was in the right direction, but it's not a divide and conquer problem. It's like a subtract and weaken problem, maybe. I don't know. So instead of trying to break the string S into two halves or along any arbitrary index, you want to try to just remove one index and just consider rabbi with three B's. Hmm. Now you ask yourself, is it possible? No, you don't ask yourself anything at this point. Uh, let's go back all the way, just reduce it all the way to just R. Is it possible to find a substring of just R which has rabbit in it? The answer is obviously no. So what I'm going to try to do is reduce uh, the string T by 1. And I'll have to keep doing this until I just end up with R or any substring which is smaller than S, because it is like impossible to have a substring in S which is larger than the whole string itself, right? So you gotta make sure that T is at least equal to or smaller than S. So I'm gonna do that all the way till I just have R. Okay. Now here, I think the answer is trivial. So when I'm just dealing with uh, S and R shortened to their first characters, the answer is 1. In this case. It might be 0 in some other examples, but in this case, it's going to be 1. Next, what am I going to do? I'll try to, I guess, extend S. So now I'm dealing with S as RA and T as just R again. So we are solving for DP21. And how do I utilize the answers of DP11 and maybe just that at this point? How do I utilize that to solve for DP21? In this case, it's going to remain 1, but what is the generalized uh, like equation to this? It has to be some equation which has uh, the previous values of dp uh, with some operator. I think it's going to be dp11 plus is the last character of s, which we have just included, equal to the last character of t. If it is, in this case, if a were r, not, right now it's ra, but if it were rr, then I would add 1 over here, because that's how you'll have dp2 of 1. Let's look at another example, or let's try to continue with this. What about dp2 of 2? Okay, so dp3 1, dp4 1, dp5 1, and so on will all be 1, because the last character of s is never going to be equal to uh, the last character of t, which right now is r. So let's move on to dp2 of 2. When when I'm in the diagonal of this dp2d array, um, I just got to compare the strings. Is the substring of s from 0 to 2 equal to the substring of t from 0 to 2? Because you cannot have like any other uh, substring with an s apart from the whole string itself be equal to t when both of them are of the same length. So I'm just going to compare RA to RA of t. And in this instance, it's equal. So I'm going to uh, mark it to 1. dp2 of 3 is like an invalid index because you cannot have t be greater than s. So let's move to dp3 of 2. How can I utilize dp2 of 2 to try to solve this? So right now my s is RAB and t is RA. Again, I think I can just uh, fall back to the original condition, which is the last character of T equal to the last character of S? Because if it isn't, let's assume that it's RAR instead. S is now RAR. That doesn't help me. I need it to be A in order to make another substring combination. So with RAB, it's again going to be just 1. Eventually, I'm going to have, yeah, I think this is the answer. Uh, so here are the conditions. So dp x of x, which essentially means I'm iterating over the diagonal, is always going to be 1. dp I j, where j is greater than I, is always 0, because this is just nonsense, because t is larger than s. And dp I of j is equal to dp I minus 1 j plus is the last character of of t, which is t of j, equal to s of I. Yes, I think this is the answer. Let's try to verify this with ChatGPT. Okay, so I think I have a good idea, and I'm really confident in my approach right now. So here's my approach. I'll just uh, explain it to you. I'll try to explain it to you, and if it's right, just let me know, because I don't want to waste time trying to implement this. Uh, so I'll have a memoized, a kind of memoization vector, a 2D memoization vector, which is going to be a 2D vector of size, uh, the length of s and the length of t. Maybe plus 1. I don't know. I don't know the implementation details, but maybe having plus 1 helps. Uh, Across the diagonal, by diagonal, I mean the indexes where uh, the row and the column number are equal, the answer is always going to be 1. No, the answer is not always going to be 1. The answer is going to be, is the substring of S and T from 0 to row number, or from 0 to column number, equal? If yes, then the value over there is going to be 1. If not, it's going to be 0. Uh, this is because when we have two substrings of equal length, the only way that substring T is present in substring S is if they're both equal. The next condition is where uh, column is greater than row. In such cases, what that means is the substring T is longer than substring S, which means that it's impossible to have a substring with an S be equal to a larger string than itself. So the answer here is always going to be 0. Uh, in the cases where, uh, in other cases, which are not what I just covered, it's going to be dpi of j equals dpi minus 1j plus is the last character of t equal to the last character of s, in the substrings that we are considering of t and s respectively. If yes, if the last characters of the substring are equal, I'm gonna add 1 to dpi minus 1j. If not, I'm just gonna copy over the previous value as it is. Do I have it right? Okay, so instead of plus 1, it should be another dp state. Hmm. I think I need a better example to like visualize this. The rabbit example probably doesn't naturally lead you to this intuition. Uh, you're adding one more character. So if there is x ways, and if it's equal, okay, if there are like 5 ways, let's say there are 5 ways to have that substring. Let this be s, or let this be c1 to cn, and this character is also cn. So there are 5 ways to get this, right? So what I'm trying to say is uh, our string t is c1 to cn, a sequence of characters n length long, and we can call it c1, c2, all the way to cn. Uh, the new character which I'm adding by extending substring s is cn. So this is the interesting case, and there are 5 ways already. Without adding cn, there are 5 ways already. So I think it's gonna be 5 plus 5, right? Because for each of the valid substrings which already existed, I can like get rid of the last cn and replace it with the one I have, the one which I just added to the substring. Okay, is it instead of plus 1, it is dpi minus 1j again? So essentially dpij becomes 2 times dpi minus j. Wait, no. But this doesn't work for the rabbit example, right? It's 1 over here. It's 1 plus 1. So it's 2 at this point. It's so we have two ways. We have RAB1 and RAB2. With B3, it's RAB3. So, okay, so something's wrong. Okay, wait, I think I got it. I need to find out uh, in this substring how many ways are there to arrange just RA. And to that, I'll add, that I'm going to add B to the end of, which is new, which is unseen in the previous, uh, possibilities that we have seen. So my condition then becomes dp I of j. Okay, wait, I'm writing something. Forgot to pull that up on stream. Uh, Pop out more options. How do you pop this out? Used to be a button. Okay. So dpi of j is equal to dpi minus 1 j plus dpi of j minus 1. So this is the right, I guess, equation for how you generalize the DP problem, the DP solution, sorry, for this problem. Is the answer dpi minus 1j plus dpi of j minus 1? Okay. No, I think I had the right intuition, but I just messed up. So I think why it shouldn't be I of j minus 1, the second term, is because if the characters match, it's going to be a problem. Yes. Because here, it's RAB. B is a new character different from A. But if it were RAA, then that would be problematic. Cool. I guess I'll stop now. I mean, we can implement this, but I guess once you have the equation for DP, it's pretty trivial. So I'm just gonna stop now. Thanks for watching. Have a great day. A great night actually, because it's almost 2:26 a.m. in India. But it's fine because Friday is a holiday because you have something called as Labor Day over here. So 1st May is always a holiday for people who work. Great. See you tomorrow.